This problem is another calorimetry problem. It's a little more specific, a very particular kind of calorimetry problem where two substances at different temperatures are brought into contact with each other. There will be a transfer of heat between them, and eventually they will reach thermal equilibrium. They will have the same final temperature. So in particular, we've got copper pellets that are at very high temperature, 395 degrees centigrade, and they're being put into a sample of water that is only at 12.5 degrees centigrade. So I know I'm going to want to use an equation we've employed several times, and this is a statement, this equation is a statement of the fact that the heat lost by the copper is going to be equivalent to the heat gained by the water. Important though, very important, essential to solving these problems is remembering even though their values, the magnitude is the same, they're going to be opposite in sign. One is an exothermic process, it's losing heat. One is an endothermic process, it's gaining heat. Now I don't know the actual heats that the copper and the water exchanged, but I do have expressions that I can substitute in for these values that will then have particular properties that I can assign values to. So I use my Q equals mc delta T, and I substitute in for the heat of the copper and the heat of the water. So everything on the left side pertains to copper, everything on the right side of my equation pertains to water. I now go back into my statement of my problem, and I start looking for the values that I can plug in for mass, specific heat, and change in temperature. So I looked up the mass of both the copper and the water. I went to a table to look up the specific heats. I make sure that the specific heats are utilizing the same units. In this case, they're both expressed in calories. You notice that the only variable is the final temperature, T2, which will be the same for both the water and the copper when they reach thermal equilibrium. I don't forget the negative value, negative sign out in front of the copper values, and I'll make sure that I distribute that as I distribute my numbers across that binomial. And so that's my next step. I go ahead and do my distribution. You notice that I followed significant figures when I wrote my final product. I now consolidate values. I put my constants over on the left side of the equation. I put my variables over on the right side of the equation. I then solve by dividing through by 288, and I got a value of 29.9 degrees centigrade that represents the final temperature of both the water and the copper. A quick check, I know that the temperature had to fall between 12.5 and 395. If your value does not fall between those two values, then obviously you've made a mistake. Often it's going to be an algebraic mistake. Often it's going to be forgetting your negative sign in your original equation.